Doctor.
Thank you for responding, Farhana. So we have, I think, many students now. I think I'm going to proceed with the class. So let me see, Fajrina, saya belum lagi take ke. So I'm going to see your attendance. Fajrina belum. So, Farhana, I nampak dah tadi kan? Okay, Farhana dah ada. Lepas tu, Hanisa dah ada. Hanisa Mamat Fuad dah ada. Hanisa Mamat Fuad dah ada. Belum Alright. Sangeeta, are you here? Not yet. Teo, Chihan, are you here? Oh yeah, saw your name. Alright. So I think I'm going to proceed with the class. Right? How are you guys? How are you, everyone?
Good, Doctor.
Good. Anybody streaming from Langkawi or Pantai, whatever? Anybody is actually in a holiday right now? Or dah kat kampung ke? Streaming from kampung? Nobody? So,
At home, Doctor.
From home, okay, same. Okay, pandemic can't go anywhere. So today, actually, with you guys on your part is done for SKO3023. What I mean by that is that there's no more assessments. Kalau ada pun maybe exercises, but yang tu nanti I tengoklah whether I'm going to do it or not, or just maybe you just review the YouTube video from my channel or something for next week, because next week we're not going to do class, so that will be asynchronous week, and that will be week 12. Okay, so with regards to assessment, there will be no more quizzes. All right, so you have submitted all your group assignment as well as your lab report. With regards to that, those that haven't submitted, I think about 2 students saja as for lab report, and I have contacted them personally, and one actually has submitted, another is still pending. And the rest, I thank you for your commitment to the course. Some actually submitted way earlier, okay, with regards to the 2 assessments. So your part is done, so my part is remaining. And I was told that for final assessment, there will be, Hanisa, thank you for joining in. So Hanisa is here. So I tinggal Sangeeta saja yang tinggal belum. Okay. So there will be schedule, I think, that will be arranged for you for the final assessment data. The faculty will inform. And this is week 11. Week 11. So we have 4 weeks remaining. Today, we'll be tackling alcohol from beginning to the end. That means I will cover IUPAC naming, properties, synthesis, reaction, and a little bit of mechanism. Okay, alcohol is not something new, something that you have seen before. And then the next 2 weeks is the last topic for SKO3023, which will be ether and epoxide. And then the last week of week 14, and then we will wrap up SKO3023. Okay. So without further ado, anybody would like to say anything before I begin my class? Okay, so nobody, I presume, then we'll begin the lecture. So when I say alcohol, what do you think when I say alcohol? Like I say, say I'm on the street and then I say, I want some alcohol, for example. What would you think? What is that alcohol? What alcohol do you think that is? Nobody? Senyap je semua ni. Hello, are you there?
Yes, Doctor.
Kan? All right. Thank you for responding. Yeah, somebody.
Yes, Doctor.
Thank you. Thank you, Sanasri. Okay, now, if I say alcohol, the large people on the street will say, you cannot drink alcohol, that's wrong, or whatever. Because essentially when they think of alcohol, they think of this. Well, to those that actually can drink Okay, those that actually can drink. Sebab you dah above 18, I'm not sure above 21 or above 18 that in Malaysia they're allowed to drink. I ask you to drink responsibly lah. Okay, so to drink responsibly, that means you limit your alcohol intake. Do not get addicted to alcohol, because alcohol can be an addiction. Because in my class, the only Muslims, we have other students as well, and we respect your culture, your views, and me being with my friends who can drink. So I ask you to drink responsibly. And people on the street, katalah dia tak pernah belajar kimia, when you say alcohol, they will immediately think about this, right? Maybe rum, vodka, maybe beer, maybe champagne, maybe wine, whatever. All right, there are so many variation of the products coming from alcohol. However, there's still this part of alcohol, okay? The part that is essential in human life. For example, people that needs to have their injections in, insulin patient, if you have wound on your body, you need to use alcohol to disinfect your skin, right? So you may use alcohol swab, for example, or maybe a large wound on your body, blood whatsoever, they will use isopropyl alcohol. Back in the days, there was some hot topic about bioenergy. I mean, energy coming from natural resources. I'm sure it is still being on, but because of the high price maintenance with regards to the energy, so that's why it has been toned down, and they will call as bioethanol, and they can come from sugar cane, that means tabu, starch, and cellulose. I don't know, many of you knows that if rum, anybody have heard about rum? It's not that popular in Malaysia, but it can comes from sugar. Okay, wine comes from what? Grapes, right? Beer coming from I believe something like yeast or something. That's why it makes you full. Okay, so it's very interesting to understand all this and to have an open view, about alcohol. So, and very interestingly, I have here is the chemistry of vodka. That means in a bottle of vodka, we have ethanol, hydrates. We also have what we call as impurities, as well as addition, so some like citric acid, glycerol. So interestingly, all of these single compounds have the chemical structure. So we can understand organic chemistry. So when we look at the structure, I say, oh, that is alcohol, or that part is benzene, or that part is alkane whatsoever, right? So it's very interesting. However, with regards to organic chemistry, this is something of alcohol that we will talk about, where the compounds contain hydroxy group. Okay, the compounds contain hydroxy group, and these are some common ones that you can find. For example, in my lab, for example, you can find methanol, you can find ethanol, you can find isopropyl alcohol, or IUPAC name as propane 2O, right? So these are the structure of water and methanol, where you can actually view them in parallel, where you just replace one of the hydrogen atom to carbon. It's very, very similar. Okay. Now, with classification of alcohol, if you remember when we did alkyl halide, you also have learned about classification of alkyl halide, and I did explain them together in parallel with alcohol. When you see alkyl halide, then you can determine what class that compound is. Further to that, you can also class your alcohol. Right. With alkyl halide, it is essential to classify the alkyl halide, because then you want to understand or determine what mechanism will take place. For example, substitution, whether it's SN1 or SN2. Okay. Now, for alcohol, why, in addition to the mechanism, what the most important thing about alcohol, if you fail to classify alcohol, then you will not be able to understand, for example, what is the product of oxidation, whether the reduction product will yield primary or secondary alcohol, for example. Okay, So that is the most essential thing about classification of alcohol. Now, if I can recall you back about the classification, okay, I will give you the same information that we have discussed before. Okay, so we have primary alcohol, secondary alcohol, and tertiary alcohol. Whatever the case is, the most important thing is to look at the carbon with your OH. No matter how long the compound is, no matter how big the compound is, if you want to determine what class of alcohol that is, you look for carbon with OH. All right. Now, for tertiary alcohol, hold on. Okay, you will have no hydrogen whatsoever that attached to the carbon with OH. Okay, the structure can be looking like this. The focus will be on the carbon with OH, no matter how long your compound is, okay? Right. However, for secondary alcohol, it has to have one hydrogen. It has to have one hydrogen, and then maybe here is CH2CH3, and here is CH3, for example. Okay? So what you need to see is the carbon with OH. And this one pula, they must have at least 2 hydrogen. Okay, it must have at least 2 hydrogen. Perhaps it looks like this, you know. In addition to that, if it doesn't look like this in terms of molecular formula, if I have, for example, cyclohexanol, right, with OH like that, and then that particular cyclohexanol there is actually also a secondary alcohol because over there you have 1 hydrogen, same thing. Or if I draw this like that, a very complicated structure, for example, but at the end here I have OH like that. So essentially this particular carbon has 2 hydrogen, then there is also will belong to the primary alcohol. Okay? So if you go to the alkyl halide, there are some explanation about its molecular trigonometry, but well, for alcohol, the most important is the oxidation product. Okay. So these are further example of classification. You can see the focus will be, whatever the case is, you look at the one with the OH. You will disregard the rest. Okay. Well, you know, just look at these ones. All right. So these ones are the 2 hydrogen, therefore it is a primary alcohol. This one got 1 hydrogen, secondary. This one doesn't have any hydrogen. This is tertiary alcohol, and this is what? This is the derivatives for benzene. Where have you seen benzene? In the topic of resonance. So it belongs to an entirely different group of compounds. We call them aromatic. That means they will undergo different reactions, which I will not give you in detail. That means because you will later learn this in SKO3023. Okay, but what you need to know about this is when you add OH to a benzene, you will call them as phenol. Okay. So these are some physical properties. Interestingly, you can see that alcohols have high boiling points due to the hydrogen bonding between molecules. Okay, high boiling points due to hydrogen bonding, and some alcohol are actually miscible in water. Miscible doesn't mean it's soluble, but it blends together. Okay, miscible means it blends together with water, where solubility will decrease as the size of the alkyl group increase. Okay, maksudnya the more part of the non-polar part, of course, it will be less dissolved in or miscible in water. Right? Now, acidity and basicity of alcohol. Usually when I talk about alcohol, this is a rare chapter that I'm going to tackle, okay, acid and basic. However, when I look into your proforma or your plan for the course, I saw that there is the need to discuss the acidity and basicity. So if you still remember about KMPKA, okay, the solubility constant, or the constant, you can refer back to your degree here, but tak adalah organic chemistry sangat di sini. It's just it's just something that needs to be discussed. But interestingly, you can see that phenol is more acidic than cyclohexanol because of the conjugated base of phenol, okay, which has been stabilized by resonance. Okay, among all of this information, I think that is the most significant part, whereby you can see the acid, although it is an alcohol, you can see that it is a weak base. Okay, however, the phenol is acidic, slightly acidic than cyclohexanol because of the conjugated base, right? So reaction of alcohol with metal. Alcohol can react with metal, forming an alkoxide. This part is what we call as alkoxide. Okay, if you look at this slide, it's sort of hanging, tergantung. What is being it used for? You know, you don't understand. You know, it's like ionic compound, really, because we have exact distinguish between the two charges, right? So where is this being useful? Later, you can use this with addition of any what do you call this? Alkyl halide to form ether. Okay, which we will call them as Williamson ether synthesis. So having an alkoxide is a precursor, okay, to make or to synthesize ether, which will be on your last topic, right? Now, this is essential to understand about IUPAC nomenclature. Okay, now, for alcohol, it's not entirely a different thing, because we have seen and we have understand what is the IUPAC nomenclature prior to this coming to this topic, and you can see that for IUPAC nomenclature is the same. You know, find what is the highest functional group present in the compound, and then use that, and then find the longest chain contained in that functional group, and then you number your substituent, or if there's double bond or triple bond present in your compound, or perhaps you have other functional groups. Right now, what you need to do is you just drop an E from in to all, you number the chain, giving the OH, okay, not OH essentially, but the carbon with OH, okay, carbon with OH group, the lowest number possible, and then you will settle all the substituent and write them in alphabetical order. So these are example of nomenclature. Perhaps ethanol, okay, if you can recall, when you have all at the back, that means we have alcohol as the highest functional group. Et meaning it has 2 carbon, right? So benzyl alcohol is quite a different one. And then you have cyclohexanol. How do you know this? Because you have cyclohexane, and then with the presence of all, that means 1 hydrogen, 1 hydroxy. Okay, you might have a tertiary alcohol here, example of 1-methyl cyclopentanol. Very interesting, because we have cyclopentanol there, and then a methyl substituent. Okay, so this is a good slide untuk you try to understand the naming for IUPAC. Now, what if we have other functional groups such as the double bond in the compound with alcohol? That means that later we will look at the priority, but largely you should know that alcohol sit higher than alkene. Therefore, alkene will become the substituent. Okay, so if I redraw this in skeleton, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and I have OH there, and I have double bond there. Okay, some student dia akan start numbering daripada kiri ke kanan, from left to right, which is wrong. Okay, this is the typical error that student can make, because dia nampak double bond, so straightforwardly dia pun prioritize on the double bond, letaklah kiri ke kanan punya numbering. That is wrong. Okay, firstly, you have to find what is the functional group, the highest functional group in the compound. So in this case, dia adalah alcohol. So whatever the numbering that you should do, or the longest chain tu, you mesti masukkan the OH. Okay, you have to masukkan the carbon with OH. Kalau lah dia ada so long punya chain, tapi the OH part is small, for example, I have, something like this, but my alcohol part is just there. And then this is not a good example, but so you have to include the part with katalah ni pun ada panjang-panjang lagi, So whatever the case is, you have to include this carbon there. Okay, that's what I mean by that. All right. So let me erase this before you get confused. Okay, in this case, then you will number them from here, because numbering from left to right will give the COH number 4, which is a high number. Okay, so 3, 4, and 5. Right? Therefore, from here, you have 5 carbon. So 5 carbon is pent. We know that, right? And then we have functional group, which is all, right? So where is your all? Where is your all at carbon 2? So we're going to put 2 here. Now, is there other substituent? Yes, we have in, which is for C double bond C. Where is it? It's at carbon 4. Remember, it's not at 5 because you first see the double bond at carbon 4. So you're going to put 4 here. Taking all of this information there, then you can conclude your naming as that one. Pent, 4 in, 2 all. Okay. However, some students say, Doctor, I prefer the old IUPAC. Then you are free to do so. But my preference should be a new IUPAC, because essentially new IUPAC is detailed and it tells me the story, where is my substituent, where is my functional group, etc., etc. And the error that you can make for IUPAC naming is for the new IUPAC naming is actually less than old ones, because it tells you where everything is. Okay. Now these are the naming priority for SKO3023. This is your boundary. Okay, this is your boundary, because the rest up here will include what we call as carbonyl. Okay, we did not tackle amine, however, for SKO3023. Now, if you look at this, then your alcohol is the highest functional group for SKO3023, where halide will be the lowest. Okay, therefore, everything you see Br ke Cl in your compound, you would not say that will be your functional group. Always, it will be substituents. However, even though we have placed our line between the carbonyl containing compounds and the non-carbonyl ones, in this alcohol topic, you are going to see the carbonyl part, because it is essential, especially for synthesis and reaction of alcohol. Tidak dapat tidak, you're going to observe the carbonyl containing compounds for SKO3023 just for the purpose of reaction and synthesis, right? Not to understand them really. Okay. What if we have a higher functional group than alcohol present in the compound? For example, okay, the numbering here is wrong, where you have carbon 1, carbon 2, carbon 3, and carbon 4. And we have carboxylic acid there. Because before I terlupa, all the carbon, okay, alcohol containing 3 and more carbons. Alcohol containing 3 and more carbons, you should do the numbering, where is your OH, okay? Because propan 1 all is different than propan 2 all. So just that for 3. So 3 carbons and above. For alcohol, you have to do the numbering. However, for ethanol and methanol, you don't need to do its number for the carbon. Okay? So if we have a higher functional group, then you are going to do and prioritize your naming on the numbering to that high functional group. In this case, acid. So in here, our OH now become the substituent. And it is called as hydroxy. It is called as hydroxy. Therefore, it's named as 4-hydroxybutanoic acid. Just so you know, why did we, for carboxylic acid, why did we didn't put any number on the oleic acid? Because it will be always carbon 1. That's just the solution that you're going to come across. Kalau kita ada carboxylic acid, the functional group, we always sit at carbon 1. That's why we don't need to put the numbering. So in this case, the name is 4-hydroxybutanoic acid. These are some common names. Perhaps if you go to, pharmacy, or if you want to buy chemical from supplier, if you say 2-methyl-propan-1-ol, maybe it's nobody could understand you, maybe. Okay, so it is called as 1-cyclobutyl alcohol. Okay, isobutyl alcohol. The IUPAC naming is 2-methyl-propan-1-ol. Okay, now, where did we come across this diol? If you remember, and if you can recall, when alkene is reacting with potassium permanganate, cold and dilute, okay, you will have diol as a product. If you remember that, for example, you have, an alkene there, and you react with KMnO4, potassium permanganate, cold and dilute, for example, and dilute, and your product will be diol. I don't know whether you can recall this, but okay. So how do you then name diol? So essentially, you just write where is your OH, okay, number your OH, then you will spell out where is your numbering. For example, here carbon 1 and carbon 6. Again, the numbering here is a bit wrong. So 1, 2, 3, 4, 5, 6. Okay. So 1,6-diol. Remember di because it has 2. Okay. If it has 3, for example, later, then you will write it as triol. Okay. Now, phenol nomenclature. For phenol, it's very straightforward. You just take. You're not learning about meta and para yet. So I believe it is sufficient untuk you understand about the numbering lah. 1, 3 and 1, 4, for example here, 3-chlorophenol. Okay. So there are so many ways to synthesize alcohol. Today we are going to. Oh, Sangeeta, you're here. Okay. So Sangeeta left. So there are, today I will write it down how many. Hi Sangeeta, I saw that you're in and out, but that's okay. So thank you all for attending. I think I'm going to see how many participants that I have for now. Sekejap ya. Oh, I think I have. Okay, I have 21. Everybody's here. Yeah. That's okay. I saw you. That's okay, Sangeeta. I saw you. That's okay. I just because it's okay. So thank you everybody for coming in. Okay, so we're going to continue, right? So where were we? Okay, for synthesis for alcohol, I'm going to discuss in 3 parts. So synthesis of alcohol. The first one, you're going to synthesize using Grignard reagent. Okay, that means RMGX. Reacting with any C-double-O containing compound, for example, whatever this could be, ester, acid chloride, or whatever, Grignard reagent. Okay. Secondly, you will look at the reduction. Okay, how to synthesize alcohol. Okay. Secondly, reduction of alcohol from a higher functional group using reducing reagents such as sodium borohydride and lithium aluminum hydride. Last one of the synthesis of alcohol, we're going to reduce juga reduction using catalytic hydrogenation with rainy nickel. Okay, with rainy nickel. Okay, the first one is synthesis of alcohol, Grignard reagent with carbonyl compound. What is Grignard reagent? When you actually react your alkyl halide with the magnesium, and you will form a Grignard reagent. A very useful reagent, because using this, not only that you will get alcohol, but you will have additional carbon. You will have additional carbon in your compound. Okay, I'm just going to go straight into this solve problem. Okay. So the question asks, show how you would synthesize the following alcohol from compounds containing no more than 5 carbon atoms. So it's syarat this here, no more than 5 carbon atoms. All of these 1 to 3 solution down here is correct. However, looking at the syarat yang dia letak kat situ, that means 5 carbon, the lowest one is the final answer lah, because it says no more than 5 carbon atom. If you see here, how to solve this? That means your beginning, you have to separate or dissect the compound. Okay, it can either be, for example, coming from CH3 as the Grignard reagent, for example here, or it could be this part ethyl here as my Grignard reagent, or the part of cyclopentyl. If you see here, the first one, using CH3CH2 MgBr, okay, we can use a ketone there, okay, as your carbonyl containing compound. So apa yang dia akan buat sebenarnya, dia akan tambah saja. You see here, dia akan tambah satu ethyl kat sini dia tambah methyl, nampak tak? And then dia reduce the C double bond O punya part kepada OH, and that's it. Okay, if you see here, okay, that's the change yang berlaku kat sini. Alright. However, although the 2 is actually correct, but it says no more than 5 carbon atom. If you calculate, the first one, okay, have 7 carbon atoms for the carbonyl containing compounds. For the ketone part, okay, this is called ketone, where you have C double bond O in the middle, and you have alkyl group next to that carbonyl, right? And then the second one also, you have 5, 6, 7, 8 carbon, so that's not right. However, the last one here, using cyclopentyl MgBr, okay, you have exactly 5 carbon for the Grignard, and then for ketone there, you have 4 carbons. Okay, you have butan 2 on there, and using ether solvent and so H3O plus hydronium ion, you will get your desired product. Okay, so macam mana nak understand Grignard, kita akan tengok dia punya mechanism with acid chloride. If you remember, acid chloride is derivative of carboxylic acid. Instead of having C double bond O OH, you just change the OH part to Cl. That means that will be also for so that this Grignard reagent yang you can use it for mana-mana saja yang ada C double bond O, whether it's ketone, whether it's acid chloride. Okay, so dia punya mechanism, I'm sure it's very, very similar, where the first thing is you have to know about the partial positive and partial negative between carbon and double bond oxygen. We have seen this in the resonance part. So apa yang akan berlaku, okay, the alkyl from MgX will attack the carbon of carbonyl, okay, because then the pair of electron for the bond between C double bond O will be pushed forward to oxygen, because oxygen is prone untuk accept. Oxygen is prone to donate. Okay, so dia ada partial negative kan, okay, so dia akan jadi negatively charged oxygen, and then to the intermediate is not stable. If you recall that when we have a negatively charged or positively charged atom, then we have to settle that. All right, so how do we conclude that is you have another lone pair of electron from the oxygen. You are going to donate that cross, and you will expel your chlorine. Okay, remember chlorine is also an electronegative atom. So dia akan terima, and then dia akan be expelled out, and you will have additional alkyl. Kalau nampak kan, kita begin with one alkyl there. So these particular ones is tambahan. Not only that you ada reduction of C double bond O, tetapi you boleh tambah you punya what is it? You punya compound. So this is a very good solution. Say you want to have additional carbon in your compound. You tak tahu nak bawa carbon daripada mana, you can use grenade. Okay. So after that, this ketone part, okay, this ketone part will be reduced to CH3O plus menjadi alcohol. Okay, so this part is the simplified mechanism that you can observe. All right. Okay, now although grenade is quite popular, however, grenade will add one atau several alkyl substituent ke dalam the carbon that we want. Katalah we just want exactly the same number of carbon. So how do we do that? We will reduce the carbonyl. Instead of adding grenade, kita akan just reduce dia menggunakan reducing agents such as sodium borohydride and lithium aluminum hydride. Now these two, although it looks very similar on paper, but dia punya reactivity is very different, whereby lithium aluminum hydride is the stronger reducing reagent where it will reduce all carbonyl. However, for sodium borohydride, it only limits to reduce aldehyde and ketone sahaja. Okay, so you can see reduction of aldehyde will give primary alcohol. This is the reason that I said that, you know, you must understand about classification of alcohol, right? Now, reduction of ketone, you will observe secondary alcohol. I'll give you some example. Katalah, let's say you have this compound here. Okay, let me draw a compound like that, and I have C double bond O, you know, like OH there, and then I have C double bond O there, a ketone part. So that one, the one in the middle is ketone, and then the one at the end is carboxylic acid, right? Using lithium aluminum hydride. Using lithium aluminum hydride, what did I? 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Okay, remember ini yang kesalahan pelajar selalu buat. Sebab we do not have 7 compounds. We do not have 7 compounds sebab kita ada berapa saja. Okay. Ini pelajar selalu confused. Kita letak 1, 2, 3, 4, 5, 6 sahaja. Yang bahagian ini adalah the tricky part yang pelajar selalu salah sebab dia nampak bond itu and then dia kira bond itu sebagai a carbon. So it's not 1, 2, 3, 4, 5. So we only have 6 sahaja. Okay. And this part will be changed into OH, will be reduced. What I mean by that is reduced. Okay. And the carbonate, this part also will be reduced to OH. Okay. So we only have 6 carbon here. Okay, kadang-kadang pelajar dia ambil yang at the end there is another carbon, which is immediately wrong lah. Okay. If you use sodium borohydride, you will observe the preservation of COOH part. Okay, but the C double bond O have been reduced to alcohol. That's the difference. Okay. You know, because you are essentially discussing about alcohol, so I did not mention if you just want to halt the reaction or stop the reaction until aldehyde, you have the option of doing that as well. Tetapi with a different reducing reagent that is called as lithium triterbutoxy aluminum hydride, yang itu akan stop until aldehyde saja. Memandangkan our topic is alcohol, so I'm just going to say this and this alone. Okay. So mechanism of hydride reduction. Okay, you will use your hydride ion. This is a good short mechanism. Kita tak bermula dengan all the big giant structure of lithium aluminum hydride. Straightforward, guna hydride ion saja. H with 2 electrons and negatively charged. Okay, hydride ion. Dia akan kepada carbon, which is the most electron positive atom. And it will be pushed forward, okay, menghasilkan alkoxide ion, and there After that, you akan react them with water and trivially you akan dapat alcohol. Okay. So these are examples of sodium borohydride reduction that you see from aldehyde and ketone perspective. So you see with aldehyde, you will observe primary alcohol. With ketone, you will observe secondary alcohol. So there's a reason later you will see why did we not observe tertiary. Okay. Reduction with lithium aluminum hydride will add 2 hydride to the ester, and mechanism is very similar to grenade or ester comparison. If you use sodium borohydride and lithium aluminum hydride, where you see for sodium borohydride, this part did not reduce. Okay. However, with lithium aluminum hydride, we reduce every carbonyl that is in our compound. Okay. The third type of synthesis of alcohol is, we call them as catalytic hydrogenation. You have actually seen catalytic hydrogenation. Where? From alkyne to alkene. From alkene to alkane. Okay, using hydrogen with palladium, nickel, or platinum. However, if you want to reduce our carbonyl containing compound, the use of palladium or nickel is not that reactive, so you can use what we call as rainy nickel. Okay. However, this catalytic hydrogenation not only reduce the C double bond O to OH, okay, it also will reduce every double bond or triple bond that is present in the compound. Okay, so you can see here the double bond there is also being reduced in addition to the carbonyl part. Okay, so itu yang specialnya rainy nickel. So dia akan jadi less popular lah sebab dia akan reduce everything. Usually kita akan preserve some parts. Okay. So that is that for reactions, or sorry, synthesis of alcohol. Do you have any question on that? If there's no question, I will proceed with type of alcohol reactions. Now, untuk type of alcohol reaction ni, it's not a new knowledge. Okay, it's not something that you haven't seen before. It's not an alien. Okay, it's something that you actually have seen. For example, the first part, dehydration of alkene. You have seen the topic of synthesis of alkene. You have seen this. All right, then this one you have seen in the topic of synthesis of alkyl halide. All right, you also have seen this reduction to alkane in the topic of alkane. All right, so the very good thing about this part is that not only that we're going to discuss them as reaction of alcohol, but it will be also the synthesis of ether. That means when we are going to topic of ether in week 13, this is something that you have seen. All right, now the first one, this is a good summary table. Although dia tak spell out the compound to looking macam mana, but it just tells you using dehydration of alcohol, you akan observe functional group that is called as alkene. Okay, you can observe oxidation, menghasilkan ketone, aldehyde, and acid. You know, reduction will give you alkane, substitution will give you halide, and the rest. Okay. Now, oxidation of secondary alcohol. Okay. Now, there are several oxidizing reagent that you can use. Okay, among the popular one is actually this one. Yes, sodium dichromate, Na2Cr2O7 in H2SO4. Okay, or maybe potassium dichromate. Okay, several reagent, or you can use sodium hypochlorite there. Okay. So any oxidizing reagent that you use here will actually oxidize your secondary alcohol to ketone, to ketone, you know. So what is actually happening? You just eliminate one hydrogen and eliminate the OH, so the two hydrogen from one is next to the carbon, and then the next one is the hydrogen of hydroxy. And then you will form your C double bond O. Okay. So the mechanism of oxidation, I want you to observe this one. Okay. and then oxidation of primary alcohol to carboxylic acid. It's very, very interesting. Why is this slide is very crowded? Because I want you to see the difference. So primary alcohol can be either oxidized into aldehyde. Okay, if you see on the priority of functional group, we have aldehyde is actually lower than acid. So you have aldehyde and you have acid there. So alcohol can be first oxidized to aldehyde, or it can be further oxidized to acid, or it can be straightforwardly from alcohol to acid. Using a strong oxidizing reagent such as sodium dichromate and H2SO4, you will observe straightforward product of carboxylic acid. See, on the left hand part, you use a strong oxidizing reagent. Okay, so it says here, oxidizing agent is too strong to stop at aldehyde. So dia akan terus proceed kepada alcohol. However, say you want to halt the reaction, you want to stop reaction onto aldehyde sahaja, you will use a particular reagent that is called as PCC or pyridinium chlorochromate. Okay, it suffice for you to just write PCC and your product will be halted at aldehyde. It's very interesting with regards to reaction of alcohol. Kalau macam I mentioned tadi, kalau daripada reduction kan, kalau daripada acid, you nak reduce kepada alcohol, you use lithium aluminium hydride. Tapi kalau you nak selectively reduce to aldehyde, you will use other reducing reagents such as the one that I mentioned previously, lithium triterbutoxy aluminium hydride. Tapi sebab kita tak belajar kan, so it's just a knowledge for you guys, but this is very interesting, oxidizing primary alcohol. Now, tertiary alcohol cannot be oxidized. Okay, so carbon does not have hydrogen, so oxidation is difficult and involves the breakage of carbon-carbon bond. Essentially, rationally, if you look at formation of C double bond O, apa yang akan berlaku is you are going to add another bond to your carbon with OH, right? So if you look at, for example, tertiary alcohol like that, say you want to add the bond here, C double bond O. So this particular carbon already have 1, 2, 3, 4, 5 hands. That's why tertiary alcohol cannot be oxidized. Okay. So these are the other oxidizing reagent. You can use sodium hypochlorite that is present in our household bleach. Okay, and you might also want to use sworn oxidation, which product is quite similar to PCC, where it only halted aldehyde, although it's not as popular as PCC because the use of DMSO. Okay, DMSO with oxalyl chloride and hindered base. Reduction of alcohol. Okay, ini, where did we have seen this? Okay, this is the reactions of alcohol. Making alkene and then proceed to alkene. Where did we have seen this? Where have we seen this? Where? In the topic of synthesis of alkene. Ada dalam synthesis of alkene using H2SO4 dengan heat. Okay, alcohol reducing to alkene. Alright, now always remember when you want to reduce forming a double bond, you have to follow Zaitsev rule. What did Zaitsev rule say? That it prefer product with more substituent, meaning less hydrogen. Go back to the topic of alkene and dig through that information. Now, reaction of alcohol with HBr. Where have we seen this? Where have we seen this? In the topic of synthesis of alkyl halide. Ada dalam synthesis of alkyl halide for substitution reaction between alcohol and HBr, for example. Yang ini just straightforward guna substitutekan the OH part with the Br part there, and you will observe something like that. Very interestingly also, you akan discuss the punya mechanism. When we talk about synthesis of alkyl halide, you just learn about this straightforward reaction. Meaning ada reactant, ada reagent, ada product. That's it. But in this chapter, you will also look at the punya mechanism. Okay, kalau you recall balik SN2 akan prefer primary. So whether it's primary alkyl halide, in this case it's primary alcohol. Kerana apa? Always remember about less hindered lah. And then kalau SN1, dia akan prefer tertiary and secondary because of the, what is the keyword for SN1? Carbocation. Okay. So SN1 mechanism using tertiary and secondary alcohol, they will react with SN1. Kalau you tengok this one is what? Tertiary alcohol. Okay, tertiary alcohol. So this one is tertiary alcohol. So how did the reaction take place? If you recall SN1, unimolecular reaction. Dia ada satu saja reaction dan the keyword here is carbocation. Nampak carbocation, dia akan jadi SN1 atau E1 for elimination. So what is happening? First one is you have to protonate. Protonate, what is being protonated? Your OH2. So the lone pair from oxygen will be moving towards your hydrogen from HBr. I just want to straightforward showing you this part. Kalau kat sini you tengok dia terus jadi H+. Mana-mana pun boleh. Okay, if you use yang ini pun juga boleh H, and then you tunjuk the bond between H and Br being donated towards Br. Okay. So we observe a positively charged oxygen, and then because it's not stable, then we can further break the H2O punya part tu, O and H hydrogen tu punya part, observing H2O as a byproduct, and we left with carbocation. So proton, so carbon that is positively charged. If you can remember carbocation, tertiary carbocation is more stable than secondary carbocation. Kat mana nak dapat information ni? Kat dalam mechanism for alkyl halide. Ada maklumat ini. Alright? And then bromide will attack the carbocation. Straightforward, you akan observe the final product. Okay, third butyl bromide. SN2 mechanism, this will be used for primary alcohol. Okay, this will be used for primary alcohol. If you see here what is being absent, apa yang tak ada, what is being absent is your carbocation. There are no carbocation form. Okay, your reaction will be proceed directly towards your, terus saja, dia tak ada carbocation intermediate kat sini. And dia punya attack pun daripada behind, if you see there, okay. And you see dia punya hash and wedge bond tu pun dah tertukar ke belah kanan. Because this is not enantiomer. This is not enantiomer. If you recall, what is enantiomer? Carbon tu mesti ada 4 substituent yang berbeza. In this case, it has 2 hydrogen. So we cannot tell lah. But if you remember, another feature of SN2 is that dia akan inverse apa sahaja stereochemistry yang ada. For example, you begin with R enantiomer. Upon the mechanism of reaction with SN2, you will observe S enantiomer. Okay. How are you guys? Are you still with me? This is an afternoon. 2 days to New Year. Are you still good? Everybody, are you still with me?
Yes.
Thank you so much. Okay. So now we solve problem.
Doctor?
Yeah,
I
Valta.
got a question.
Yep.
For see, the arrow is actually reversible, right? So
Which one?
In the mechanism, right?
SN1 or SN2? Either one. Okay, yeah. The equilibrium, yeah.
Do we use it for every single mechanism, or is there a, what do you call? Syarat to use the.
Look, because for organic chemistry, the focus is the movements of electrons forming the charge, your arrows. So for me, kalau, if you talk about, for example, chemical kinetics or physical chemistry, the equilibrium or straight one punya arrow is important. Tapi kalau kita cakap tentang organic chemistry, for if you ask me, doesn't really matter. Doesn't have any syarat. Because although it's reversible, usually the reaction is more straightforward. Okay, and it's just on the talk of mechanism. Kalau there's no mark even being given to the arrow in the middle. Then we
So it doesn't matter.
when I talk about mechanism, what I will see is just what is the charge? Are you doing the right charge? Are you moving the right electrons? Are you giving are you showing me the right arrow? And that's it. I will not even give mark to the equilibrium or the straight arrows because it's not really significant. Tapi if you ask me, all the syarat and whatsoever, it's not really that significant or important with organic chemistry. You can
Right.
further, but yeah.
Okay.
Yeah, Velta, does that answer satisfy your question?
Yeah.
Okay, so usually I did not give any if you talk about assessment, but for the knowledge part, I don't think there is any syarat whatsoever lah. But that's kinetic punya part. That's kinetic. I'm sure there will be substitution and elimination kinetics, but not really my interest. But yeah, okay.
Right.
Thank you for the question. All right. Anybody else, or can we proceed to solve problem? So you see here, it's showing the reaction between 3-methyl-butanol to 2-bromo-2-methyl-butane. What's interesting about this is this. If you see here, the carbon with OH is over there at the second carbon. However, the substitution actually happening here. Isn't that interesting? Okay, why does this happen? If you recall back, what is the type of alcohol that is? What is the class? This is secondary alcohol. If you go back to the previous knowledge that we know, secondary alcohol will undergo SN1 reaction. So SN1 reaction involves, we call as carbocation. If you go back to the topic of alkyl halide, we know carbocation prefer tertiary carbocation. Okay, that means there will be what we call as, if you can still remember, we call as hydride shift. Hydride shift. We are shifting the hydrogen. Okay, we are shifting the hydrogen from the tertiary carbon to the one with secondary carbon, and then there will be observed the new positively charged carbon for the tertiary carbocation. And the Br will be added there instead of the previous place. So this is a very good example where we did not actually just replace saja your OH dengan Br. Okay, because now we know about mechanism, right? Okay. So far so good. If you see here, the mechanism is very similar. It's just the hydrogen, protonated hydrogen is being observed there instead of HBr. Mana-mana pun boleh. Kalau tadi you tengok the H and then Br, the pair of electron there being donated to Br, and then the lone pair from oxygen react with the hydrogen there. But over here, the hydrogen has been positively charged. So mana-mana pun boleh. Okay, last kali dia akan eliminate water. You will observe carbocation, and last kali you have the observed product. Okay. So reaction with phosphorus halide. Where have we seen this? In the synthesis of alkyl halide juga you dah jumpa benda ni. Alright, you use PCl3 for alkyl chloride, PCl5, or maybe you use dinyl chloride. You might also use zinc chloride with HCl. I can't remember what is it? A tolerant reagent? No. I can't remember what is the reagent there, but apa yang ada dalam you punya notes hanyalah PCl3, dinyl chloride, SOCl2, and then we have PBr3 for alkyl bromide. We have also, if you use alkyl iodide, although it's less popular, you use phosphorus and iodine instead of Pi3. Okay. So example here, it's just straightforward. You just change this part to Br. Some student ada confused sikit. Sebab dia nampak phosphorus, so they always think that the phosphorus will come into play. Maksudnya phosphorus memainkan peranan in the final product. Tak ada phosphorus tidak ada peranan kat situ. We just take the BR punya section. And then if you use phosphorus and iodine, you akan replace your OH with the iodine part. And likewise, using PBr3, you akan replace saja OH2 dengan BR. Okay, this is something that saya nak you observe sahaja, mechanism with PBr3, where displacement of bromide ion forming auxiliary leaving group and then ada SN2 attack on the alkyl group. Okay, you observe sahaja this one. This one is actually straightforward sebenarnya, whereby it doesn't have any mechanism, but what you can see here is just replacement of substitution of the hydroxy or OH punya part to Cl. Okay, leaving your gaseous HCl and sulfur dioxide. Okay, so it's very common reaction. Kalau you tengok balik dalam tajuk alkyl halide, kita bincang juga benda ini. Okay, macam mana nak menghasilkan alkyl halide daripada alkohol. Banyak cara dia. Okay, now the mechanism of Catalytic chloride also, saya nak you observe sahaja. Dehydration reaction, we have seen this and we also have talk about this for the synthesis for the mechanism. Its mechanism for formation of alkene, we have discussed them in the topic of synthesis of alkene, if you can recall. Okay, so very interesting about this, saya akan cerita nanti, is about the mentioning for the temperature. If it state heat, that means kita akan understand them as high temperature. So you will observe alkene. However, if it state temperature 140 and below, you will form ether. Nampak kat sini? You have already observed two ways to synthesize ether. The first one is using alkoxide tadi with alkyl halide, you akan dapat ether melalui yang reaction tu called as Williamson ether synthesis, or you akan observe ether from alcohol using 140, that means low temperature. Okay, 140 and below will favor ether. However, 100 for your product will be alkene. Okay, we will assume that as high temperature. Okay, so you will observe this. Also, you have to go back to Zaitsev rule for this one. Every time you are making C double bond C, you will go back to Zaitsev rule. Okay. So dehydration of alcohol mechanism, this is something yang kita pun dah tengok. We actually have seen this in the topic of synthesis of alkene. You have to go back and study this again. However, you can see here, dia apa yang memainkan peranan. Kalau you tengok towards all the mechanism that you have learned, usually dia akan, kalau ada C double bond O, kat situ akan mainkan peranan where yang one of the pair of electron daripada CO tu akan di-donate kepada oxygen. And then something will attack the carbon. Atau kita akan mulakan pergerakan daripada lone pair. Kat sini lone pair of electron from the oxygen there. Kan dia akan attack H kat situ, and then dia akan jadi positively charged oxygen, and lastly you akan eliminate your hydrogen and you akan dapat double bond. Now, if you get confused, kan, mechanism always begin with the initial part, reactant, reagent, product, and then you go backward. Okay? So mechanism of dehydration E1, okay, kalau you tengok kat sini, alcohol dehydration generally take place through E1 mechanism. Okay, kalau you tengok macam biasa the first one, ini pun you dah tengok dah sebenarnya dalam tajuk formation of alkene. Okay, synthesis of alkene. Okay. Now, solve problem, dia kata predict the product for sulfuric acid catalyzed dehydration of 1-methyl cyclohexanol. Very interesting, where this is, what is this? This is a tertiary alcohol. So you know, kalau tertiary dia akan prefer E1. Okay. So dia akan protonated, and last kali you akan dapat carbocation. So this is what? This is also carbocation. Carbocation. Okay, and then you have the options of you nak ambil hydrogen daripada carbon yang dekat keluar tu, dekat chain tu, atau the hydrogen coming from inside the cycloalkene. Okay, so this is where you akan gunakan Zide self. Alright, Zide self says they prefer product with more substituent, meaning less hydrogen. Okay, so if you see here, we only have one hydrogen there. That's why this is major product or it is Zide self product. And this one ada dual hydrogen. So, dia adalah minor. Okay, sebab dia tidaklah satisfy Zide self rule. Okay. Esterification. Okay, esterification ni apa? Semua orang pernah belajar esterification. Menghasilkan ester. Semua orang tahu ester tu wangi dan sebagainya. Caranya menggunakan alkohol dan asid. Tetapi you are learning up until there sahaja. Well, actually, ester ni pun ada dua ways lah. Satu kita panggil Fischer esterification yang use carboxylic acid atau the general esterification using acid chloride. Kenapa? Sebab acid chloride is more reactive than carboxylic acid sebenarnya. Okay? So, Fischer esterification just elimination of water from hydrogen that is coming from the alcohol part and then the OH coming from COOH part. So you just eliminate kedua-dua ni and then keluarkan dia punya H2O and then dapatlah you punya ester. Okay? And reaction with acid chloride, sama je konsep dia, you akan keluarkan HCl tu. Kalau tak ada pyridine ni, you just straightforward pun tak apa. You akan keluarkan HCl, so tengah-tengah dia akan dapat ester. Okay, the preference kalau you belajar nanti dalam SKO3023, kita always akan convert acid kepada acid chloride dulu, barulah kita akan reactkan dengan ester. Okay, sebab Fischer esterification is so reactive, so irreactive. Maksudnya sangat lambat tindak balas tu. Okay. Now, this is, what is this? This is synthesis of ether. Synthesis of ether. Dah belajar dah pun dalam topik akhir tu. Synthesis of ether using Williamson ether synthesis. Ingat alkoxide ion, kat mana kita jumpa? At the beginning of our lecture today, alkoxide ion is dia dihasilkan reaction between alcohol and metal. In this case, sodium. So, dapat alkoxide ion. Dia akan react with primary halide. You boleh disregard the tosylate tu. And akhirnya, you akan dapat ether. Apa beza this one dengan kalau kita guna alcohol with temperature tadi, H2SO4 140 and below. Kat situ kita akan dapat what we call asymmetry ether saja. Maksudnya kiri dan kanan jenis yang sama. Kalau CH3OH, gunakan tindak balas tu akan dapat CH3O, CH3. Dia symmetry. Tetapi for ether, Williamson ether, you boleh hasilkan daripada apa-apa sahaja jenis ether. Mana-mana pun boleh. Okay? And that's it actually for SKO3023. Any question, you guys? This is a lot of information and there's a lot of knowledge, but as usual, I'm recording this and I will upload them in my YouTube channel so that you can do your revision on this slide, on this lecture. Okay? So, yeah. Any question? I'm sure some of you may be trying to understand, and some of you need some time because it's late in the afternoon. It's actually, this information sebenarnya panjang. Kalau face-to-face lecture, maybe saya akan buat beberapa exercises during the lecture lah. But when I observe with online, kita kalau I buat kan, because I couldn't see you guys, so it's a challenge lah. So yeah, but this is a good opportunity if you have any question.
Doctor.
Yeah, who's that? Who's speaking? Yes, Valta.
I don't get which part is tosylation. What is that?
Tosylation? Tosylation use sulfur there. Let me find tosylation. Tosylate ester is tosylate ester, you just change the X to S. So primary halide, this is halide with halogen atom. Tosylate is sulfur here.
I cannot see.
That's all you cannot imagine.
Oh yeah, I can't imagine it.
Okay. So, for example, instead of having that, I just have, let me see. So, maybe if you use, okay, and then you react with,
You're not present.
I'm not presenting, did I?
Yeah.
Did I not? Sorry.
No,
So, I shot sendiri lah. Okay, hold on. I'm trying to find my presentation. So, I just,
okay.
all right. Okay, now you can see.
Okay.
All right. So this is alkyl halide. Okay, let me show this first and then I proceed with tosylate. Okay, so if you have something like this and then you will observe, this is not talking about, later you will consider about tertiary alkyl halide, you will consider about primary alkyl halide or what does it take place. Tapi ini straightforward saja. What you will observe is something like this. Okay. All right. Something like that. Or for example, if I use tosylate as tosyl, instead of alkyl halide. So say I have CH3, CH2, sulfur instead of X. Right? So apa yang akan dapat ialah oxygen, CH2, CH3. Sama je, the end product is the same. Boleh ke?
Also, tosylate is something with an S at the end.
Yeah.
Oh, okay.
So if you want to do a quick Google search, tosylate, if you want to do a quick Google search, tosylate is anything with an S. It's S double bond O R, something like that. Tosylate. Okay. So tosyl is essentially with an S, but because I did not tackle that a lot in organic chemistry for you guys, so that's why saya tak explain panjang-panjang. Begitu juga dengan formation of alkyl halide tadi. So this part, okay, this part could be S double bond O whatsoever, but it's something to do with S. Usually I did not discuss because sebab kita tak belajar pun tentang tosyl acid ke apa ke kan. In fact dalam SKO3023 punya syllabus pun tak ada juga. But it's helpful lah to know kan. Right? Boleh
Okay.
Even ether epoxide also, actually ether tu pun you boleh, instead of ada oxygen in the middle, you boleh tukarkan dia kepada S in the middle. I'm not sure kalau dalam topik ether epoxide nanti ada. Okay, tapi itu bukanlah ether dah lah. Okay, bukan oxygen in the middle. Tapi kita boleh ada macam gantikan oxygen dengan S. That's it, the product will be the same. Sebab kita tak cover, so saya fokus kepada alkyl halide saja. Okay, Valta?
Okay.
Thank you. So, ada lagi kawan-kawan nak tanya apa-apa? Anybody? Anybody? Nak tanya apa-apa? Oh, senyap semua hari ni?
Doktor,
Ya, Jacqueline.
saya ada sedikit confused dengan SN1 dengan SN2 tu.
Okay. Kat mana? Yang tadi tu Yang reaction HBr ke?
Ya.
Bispat Macam mana nak tentukan? Okay. Kat sini, you go back to the, I did not present again. I did not share again. Okay. So, kalau you tengok kat sini, you have to macam compare side by side dengan previous knowledge yang kita dah belajar dalam alkyl halide. So, mula-mula sekali you kena classify kan whether what class does that alcohol belongs to. Kena tentukanlah sama dia primary ke, tertiary ke, secondary. Kalau primary, you akan terus buat SN2. SN2 bermakna, apa benda makna SN2 ini? There is no carbocation. Itu yang you kena ingat kalau SN2. Kalau SN2, the most important thing that you have to remember, if SN2, no carbocation. Maksudnya tak ada carbon yang ada positively charged tu. SN1, there will be carbocation and there could be hydride or methyl shift untuk menghasilkan tertiary carbocation. Yang itu yang you kena tahu. Mula-mula tahu kelas dia apa, lepas tu baru tahu SN berapa, okay? And then mekanism dia bagaimana, okay? So, kalau you ada, for example, you know, alkohol yang primary, tapi primary alcohol SN2 ni you tak boleh observe any inversion lah, sebab kita tahu primary alcohol kena ada at least 2 hydrogen kan. So memang akhirnya you tak ada inversion atau kaitan dengan stereochemistry. Okay, tapi interesting about SN1 tadi, bila you boleh buat hydride and metal shift, you start dekat mana, Jacqueline?
Doctor have explained my question actually.
I did answer already. Itulah yang mula-mula
Yeah.
sekali bila nak tentukan mekanisme apa-apa, sebelum you even go to the mechanism, you tengok apakah hasil dia. Kalau dia just replacing one of the carbon, one of the functional group, dia mesti substitution. Tapi kalau tiba-tiba dia menghasilkan double bond, dia mesti elimination. Selepas dah tahu SN atau E, baru you tentukan betul dia adalah SN2, SN1 atau E1, E2. Lepas tu, you tengok the keyword. Keyword SN1, dia mesti ada carbocation, dia mesti tertiary, okay. And then dia mesti ada what else? Saya tak cerita tentang living group, tentang aprotic, emprotic solvent, semua tu ada lagi dia punya ciri-ciri dia. Tetapi ciri-ciri yang besar is this one. Kalau you tengok the further ciri-ciri tu, the good living group whatsoever tu, weak base lah apa benda ada dalam alkyhalide punya notes. Okay? Tapi yang most important yang you kena tengok kat sini, observation directly, is bila ada carbocation, there is a possibility untuk ada hydride and metal shift. Therefore, your product will vary. Your product will vary. Daripada macam, this is a good one, okay? You tak replace direct kepada OH tu. It's happening somewhere else. And why is this happening? Because it follows SN1 mechanism. Okay? Thank you, Jacqueline, for your question. Anybody else? Anyone? Oh, senyap kali ni. Group B. So, I'm accepting one question lagi. Kita pun 6:30 kita wrap lah. Okay? Ya, je semua? Alright. Are you excited for the new year? Nobody answering. Okay. So, yeah. If there's no more question, I will wrap up the class today. Okay. So I'll see you all the next 2 weeks. Masih memerlukan masa untuk hadam doktor. Thank you for your chat. Faris, it's a lot. I know it's a lot. Tapi you can relate back to the previous knowledge that we have seen before. So thank you for attending the class despite you being somewhere else. Kalau bukan di rumah, maybe you are in your kampung trying to find a broadband or, you know, whatever. Enjoy and have fun and take care of yourself in this pandemic. All right. Okay. So I'm going to wrap up the class. So thank you, everyone. Have a good New Year. Have a good celebration of your New Year. 2 more days to go. Happy New Year. Bye.
Happy New Year, Doctor.
Happy New Year. Oh, that's good. Shout out, Jacqueline. Bye, everybody.
Bye, Doctor.
Yeah. Bye.
Thank you. Take care. Oh, Lavindra, thank you for your shout out. Happy New Year. How did you do that? Okay, bye. Thank you, Doctor. Happy New Year. Thank you, Faris. Thank you, everyone. Happy New Year. Bye-bye. Bye, everybody. Thank you.